Welcome back, everyone. And in this video, we're going to talk about graphing linear equations in two variables, which is just graphing typical standard linear equations on the coordinate plane, which I'm sure you're all familiar with. And I'm going to graph all of our equations over on this one just for the sake of keeping them all together. And I'll just erase as we go along and draw them in different, or if it gets too cluttered, and I'll draw in different colors for the lines. Okay, so currently at our disposal for graphing linear equations, what we have, the tool we have is making tables of values, because if we're making tables of values, we're collecting essentially a table of coordinate points for these. So here, let me draw a brief table. We only really need, 2 or 3 points to graph lines because they're straight lines. They're linear. They're going to be straight lines. So what we're going to have is we're going to have x values. We're going to have y values. And then we're going to have our equation that we have to solve to get between these values. In this case, in the first one, since x doesn't have any coefficient, it might be easier if we pick y values and then solve for the x, or see what that leaves us in terms of x. So one thing that's pretty standard is to start with 0. So then if we plug 0 in here, we're going to have x plus 4 times 0, which is 0, equals 1. So x equals 1. And then if y equals, say, 1, we have x plus 4 times 1, which is 4, equals 1. So that would mean that x equals -3. And then maybe just say on the other side, we can try a -1. Then we have x minus 4 is equal to 1. So x equals 5. So if we move then over here and think about this, with our table of values, we have 1, 0, or actually, let me first, write these coordinate points that we now have. If we think about these x, y coordinates, we now have 1, 0, -3, 1, and 5, -1. So if we move over here to graph this, if it would like, oh, goodness gracious, if it would like to work for me, is 1, 0. So this is x, this is y. To graph, we always go count the x coordinates first and then the y. And obviously, if it's positive for x, you're going to move to the right. If it's positive for y, you're going to move up. If it's negative for x, you're going to move to the left from the origin, which is this point right here, 0, 0. That's the origin. That's where you always start when you're graphing. So you're going to start from the origin. If x is positive, you move to the right. If x is negative, you move to the left. If y is positive, you move up. If y is negative, you move down. So for 1, 0, we start at the origin. We go over 1, which would put us here. And then we go up 0. So that would keep us here. So then we have -3, 1. So if we start at the origin, we're going to go 1, 2, 3 to the left. And then we're going up 1 because the y is positive. So that would put us right here. And then we have +5, -1. So we're going to go over to the right, 1, 2, 3, 4, 5 from the origin, and -1 for the y. So we're going to go down 1. So that would put it, oops, sorry, I don't know why it does this. Okay, this is not what I'm trying to do. So let's not do this, please. Okay, that's about where I was before, I suppose. Okay, so there's a point there. Apparently my stylus just doesn't want to work with me. And then if we draw a line through these, this is our line. We just graphed this line. So now I'm going to erase this so we have a clean slate for the next one. Okay, so now we're graphing y equals 3x minus 2. Okay. So now we'll make another table of values. Make it purple this time. So we have x values, we have y values, and we have y equals 3x minus 2. So since y doesn't have any coefficient in front of it now, we'll start with x values. So we can pick the same, I don't know, 0. I'm just going to pick 0, 1, 2, just for ease. And then if x is 0, then we have y equals 3 times 0, which is 0, minus 2. So y equals negative 2. If it's 1, then we have y equals 3 times 1 minus 2, which is 3 minus 2, which is just 1. And then if x equals 2, we have y equals 3 times 2 minus 2, which is 6 minus 2, which equals 4. So there, now we have coordinate points again. Respectively, we have 0, negative 2, 1, 1, and 2, 4. So when we go over to graph these again, I'm going to do this. This will probably be a little bit easier. Actually, first, let me say this is x. The vertical axis is y. So we're starting with x equals 0. So from the origin, we're not going left or right, and then we're going down 2. So we're going to end up here. 1, 1 means we're going over to the right 1, up 1. So we end up here. Let me fix that just a smidge. So we're going over to the right 1, up 1, and this is where we're ending up. And then we have 2, 4. So we're going over 1, 2. Then we're going up 1, 2, 3, 4. And this is where we're ending. So now that we've seen where those go, let me get rid of the extra little dots. Okay, so now we have 3 points again. And we just draw a line through them. Sorry, I'm not the best artist here. I'm not really good at drawing. But that would be our line. So that's the y equals 3x minus 2. Okay, moving along. We're graphing 4x equals 5y plus 10. Oh, excuse me, I need to check something real quick. Okay. So now, let me see how many we have on here. Okay. For this one, It's going to be the same process. I'm just going to do something a tiny bit different. One thing to think about when you're graphing is that it's, especially on like a typical standard coordinate plane, is that it's kind of hard to graph fractions or decimals like accurately. So we always want to, when you're graphing and making a table for yourself, you kind of want to try to get whole numbers if you can. So what we're going to do for that then, 0 is a safe bet, generally here, and it's good to have 0. 0 is always an important number because it relates to the origin and where the graph crosses the axis. So here's our equation for x equals 5y plus 10. So if x equals 0, we're going to have 4 times 0 equals 5y plus 10, which means that this is 0. Goodness. Sometimes this thing just really doesn't like to work. So now we just have to solve for y. So this is 0, this goes away. So we have negative 10 equals 5y. So y equals negative 2. So 0, negative 2 is a point. Now, if we picked 1, we'd have to, or we'd be left with a fraction because you'd have 4 times 1, then you have to subtract 10, divide by 5, you'd get a fraction. It's not super pretty. You can do it if you want. So I'm going to pick 5 because I believe that it'll give me a large enough number to, and since we're dealing on the right side with multiples of 5, 5 and 10, it'll be easier that way so that we don't have to deal with fractions. So then we'd have 4 times 5 is equal to 5y plus 10, which means that 20 is equal to 5y plus 10. So 10 equals 5y, which means that y equals positive 2. And again, the reason I picked 5, just so you don't think it's some like random ambiguous choice, is because on the right side of the equation, we are dealing with multiples of 5, like 5 and 10. So it seemed like the way to go, because if I'm multiplying something by a multiple of 5, chances are we'll get some kind of whole number back when we divide by another multiple of 5. So that's kind of my thinking for that one, just for the sake of getting whole numbers. And then for a third point, we can choose 10 because it's another multiple of 5. So we'd have 4 times 10 is equal to 5y plus 10. So we have 40 is equal to 5y plus 10. So 30 equals 5y. So y equals 6. So respectively, now we have the points 0, negative 2, 5, 2, and 10, 6. So now, when we graph these, we're going to consider, so there's 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, no, there is 10. Okay. Here, okay. So now we have 0, negative 2 first. So start at the origin. We don't go anywhere with x because it's 0. We go down 2. So there's our first point. 5, 2 is our next point. So we go over 1, 2, 3, 4, 5, up 1, 2. So we end up here. And then the last one, we go over 10 and then up 6. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1, 2, 3, 4, 5, 6. So that's where our last point is. So now let me get rid of the extra dots. And now we have 3 dots to make a line with here. So there is the graph of the line from that equation we just had, which was 4x equals 5y plus 10. Okay, so now we have x equals 3y. Excuse me. In this case, again, since x doesn't have a coefficient, it'll probably be easier to make a table by picking values of y first. So here we have x equals 3y. So if we start with 0 here, we have x equals 3 times 0 equals 0. So this would be 0. If we pick 1, we'd have x equals 3 times 1 equals 3. And if we pick 2, we'd have x equals 3 times 2 equals 6. So that's a way to go there. Hold on one moment. Sorry, I just have to double check on something else real quick. All right, pardon me. I'm back now. Okay. So respective points here are 0, 0, which is the origin, 3, 1, and 6, 2. So 0, 0, 3, 1, 6, 2. So when we go up here, the first point, okay, then I wasn't at the graph, that's fine. Okay, so 0, 0 is the origin, that's our first point. 3, 1, we're going to go over to the right 3, up 1. So we're here, and then we're going to go for the next point, 6, 2, we're going to go over to the right 6, and then up 2. So we end up there. So those are our 3 points. Drawing a line through them. And the arrows just represent that the line would go on forever in either direction in that same pattern. But here we are. That is the graph of the equation x equals 3y. Okay. Now we have x plus y is equal to 0. So just for the sake of plugging things in with this one, I'd recommend just, since neither of them have coefficients or anything, I'm just going to subtract y from both sides. So we have x is equal to negative y as our equation to work with here. Because it'll just make it, a little bit faster to solve going down here. So we have x is equal to negative y, and then y. So if I pick 0 here, I have x is, 0 is equal to negative y, so y equals 0, so that's 0. If I pick 1 here, we have 1 is equal to negative y, so y equals negative 1. And if I pick 2, same pattern, y is going to be negative 2. We essentially are just negating the value here. So our points now are 0, 0, the origin, 1, negative 1, and 2, 2. So So we're essentially just going to end up with a diagonal equation, or like a diagonal graph here, because we're starting, or that passes through the origin, because we're starting here with 0, 0. Then we have 1 comma negative 1, and then 2 comma negative 2. And then when we draw our line, we're going to go through here. Sorry, that's kind of poorly drawn, but it essentially diagonally crosses through every grid here, or every grid mark here. Okay, so now we're graphing y equals negative 3/5 x plus 2. I think I picked that color over. Oop, nope, not that. Oh, I want the pen. And I want, what color? We'll do this one, why not? Okay. Okay, so in this case, we have x and y, we have our equation that goes in the middle. I'm going to start with 0 as per usual. So we have y equals 0 plus 2, so 2. Next, since we're dealing with a fraction here in front of x, I'm going to pick something that'll clear the fraction out, which would be 5. Any multiple of 5 will clear that fraction now. Because now we have y equals negative 3/5 times 5 over 1 plus 2. So these 5's cancel, so we're left with negative 3 plus 2 is equal to negative 1. And finally, I'm going to pick 10 because it's another multiple of 5, and it'll clear the denominator. So we have y is equal to negative 3/5 times 10 over 1 plus 2. So if we cross cancel, that becomes 2, that becomes 1. So this is negative 3 times 2, which is negative 6, plus 2, that's negative 4. So for our points, we have 0, 2, 5, negative 1, and 10, negative 4. Okay, so we start at 0, go up 2, that's 0, comma 2. We have 5, comma negative 1, so over to the right 5, then down 1. And then we have 10, and then we go down 4. So those are our 3 points. And now we're going to graph through. So that would be our equation for y equals negative 3/5 x plus 2. Okay. And now we have graph y equals 2/3 x minus 1. So in similar spirit to the last one, we're going to make a table. And to all the other ones, we're going to make a table. We have x and y. We have our equation. I'm going to start with 0 just to make things easy on ourselves. So we have y equals 0 minus 1, so that would be negative 1. in similar spirit to the last one, I want to clear this fraction out. So I'm going to pick 3 because 3 will clear the denominator out. So I have y equals 2/3 times 3 over 1 minus 1. This goes away. That's 2 minus 1. So that's just positive 1. And then if we pick 6, because it's a multiple of 3, we have y is equal to 2/3 times 6 over 1. This becomes a 2. This becomes a 1 if we cross cancel. Minus 1, so that's 4. Minus 1, so that's 3. So our points now are 0, -1, 3, 1, and 6, 3. Okay. So now, oh my goodness, I hate when it does that. We have 0, -1, so we just go down 1 from the origin. 3, 1, so we go over 3, up 1, and then 6, 3. So we go over to the right, 6, up 3 for that point. And then we just have to draw our line through those points. And that is our graph of the equation y equals 2/3 x minus 1. Okay, now they're asking us to find the x-intercept of the line 2x plus 8y equals 1. Okay, so something to point out here is we've done this 2 times actually already. We found the x-intercept. We found it here. And we also found it here. And all finding the x-intercept means is finding the place where the graph crosses the x-axis. So where the graph crosses the horizontal dark bar. And we do that just for the sake of demonstration. The x-intercept is when the graph passes this line, and the y-intercept, is when the graph passes this. Oh, that was not the highlighter. That is why that was not working. So when the graph passes through this line, the vertical line. So to find them, I guess to answer the question first, to find the x-intercept, we found the x-intercept both times when y was equal to 0. So in order to find the x-intercept now, we're going to set y equal to 0. So for the x-intercept, set y equal to 0. So now we'd have 2x plus 8 times 0 equals 1. Well, 8 times 0 is just 0. So we have 2x equals 1. Dividing by 2 on both sides, we get x is equal to 1/2. So that means that the x-intercept of this line is the point 1/2, comma 0. The 0 part comes from the fact that we set y equal to 0, and then the 1/2 is just solving. So this means this is the point where the graph of this equation would pass through, or would intersect the x-axis, the horizontal line that I highlighted in yellow up there. Okay, same thing down here. They want us to find the x-intercept, so we're going to set y equal to 0. So we'd have 0 equals 3x minus 18. So then 3x is equal to 18 because we have to add it to the other side. Dividing by 3 on both sides gives us x is equal to 6. So the x-intercept would be the point 6, 0. That, in other words, that is the point where this graph would intersect the x-axis, or the horizontal line that goes from the origin, from this yellow line. The green line is the y-axis, it's the vertical axis. The horizontal axis is the x-axis. This is where we're finding where it intersects. Now, similarly to that, if we have to find the y-intercept, we have also already done that, because we found when x is equal to 0, where it crosses, or where the equation crosses the y-axis or the vertical axis, and we did that in quite a few of them, actually. Yeah, in almost every single one we found the y-intercept kind of inadvertently, just because, it seemed easy, but there's a deeper reason. So for this one, for the y-intercept, we're going to set x equal to 0. So now we have 2 times 0 plus 8y equals 1. That's 0. 8y equals 1. If we divide by 8 on both sides, we get y is equal to 1/8. And so the y-intercept is the point 0, 1/8. Or this is the point where the graph of this equation would intersect the vertical axis, or the axis that I highlighted in yellow. Now, in the same sentiment over here, we're going to set x equal to 0 to find the y-intercept. So we have y minus 1 over 2 is equal to 2 times 0 plus 7 all over 3. So then we have y minus 1 over 2 is equal to 7/3. In order to do anything else and isolate y, we're going to multiply by 2 on both sides, so that we get y minus 1 is equal to 7 times 2 across the numerator is 14. 3 times 1 across the denominator is 3. And then we're going to add 1 to both sides. So we have y equals, and then we're going to think of this 1 as 3 over 3, because we're going to make a common denominator. So then we have y is equal to 17/3. So in other words, here the y-intercept is the point 0, 17 over 3. And this is the point, again, where this particular equation would intersect the vertical axis. Okay, so for the last three, we just have to find x and y intercepts, which just essentially means to plug in 0 for the other one. So here's x int here's y-intercept. So this one, y equals 0, and in this one, x equals 0. So for the x-intercept, if y equals 0, we have 3x minus 2 times 0 equals 12. Well, this is just 0. So if we divide by 3 on both sides, we get x is equal to 4. So the x-intercept then would be the point 4, 0. In this case, we're letting x equal 0. So then we'd have 3 times 0 minus 2y equals 12. Well, this is just 0. So dividing by -2 on both sides gives us y is equal to -6. So the y-intercept is 0, -6. That's the point that we're looking for. So now we're finding the x and y intercepts here. Once again, so y equals 0, so x equal to 0. Then we have 2x minus 0 is equal to 4. So we're just going to divide by 2. So that x is equal to 2. So then our x-intercept is the point 2 comma 0. If we set x equal to 0, then we're just left with negative 2/3 y is equal to 4. We're going to multiply both sides by the reciprocal, so by negative 3/2. So that y is equal to 4 times negative 3, which is negative 12 over 2, which is negative 6. So this one would be 0 comma negative 6. Excuse me, for the intercept. And then number 14 is just more of the same thing. So last but not least, we're going to solve the x-intercept first. So if y equals 0, so we have 7x plus 3 times 0 equals 42. That cancels, so we just have to divide by 7. So that x equals 6. So the x-intercept is 6, 0. And then the y-intercept, we just have 7 times 0 plus 3y equals 42. This goes away, so we just have to divide by 3. So y is equal to 14. So the y-intercept is 0 comma 14. All right, and then that concludes our video. We talked about graphing, we talked about intercepts in graphing. I hope this helped, and I will talk to you next time.